Okay, who can walk me through number 1? How do we get the answer of QL?
AQ equals 1/3 AL.
Good. AQ equals 1/3 AL.
If you're writing something, oh wait, never mind.
Can you guys see it now? Okay. So AQ equals 1/3 AL. But we're given AQ, right? So we're given AQ equals 21. So let's plug in 21 equals 1/3 AL. What do we have to do, peeps?
Multiply 3/1 for both sides.
Good. Let's multiply both by 3/1 or just 3. We should get, I think, 63 on the left?
Yeah, 63.
63 equals AL. And then from there, how do we find QL? There's 2 different ways we could do it.
Times 2/3.
Yeah, we can multiply AL by 2/3. So QL is going to be 2/3 times AL, which is just going to be, I think, 42. 2/3 times 63, which is 42. Is that right? Did you guys get that? 42?
Yeah, I got 42.
Okay. And then, or, what's AQ going to be in comparison to QL? What's the ratio between AQ and QL?
1/3.
Okay, 2/3 and 1/3, right? But if we're just looking at AQ in comparison to QL, AQ is going to be half of QL. Okay? AQ is going to be half of QL. So 2 times AQ will equal QL. Okay? I'm just doing it the exact same way. Okay? So we know what AL is and we know what AQ is. So let's just plug in AQ. 2 times 21 equals QL. We get 42 equals QL. Either way is fine, okay? So you can use the 1/3 and 2/3, or you can use, okay, I know that AQ times 2 will be QL. I'm just going to multiply it by 2. For the most part, I was actually really happy with these questions on the test. A lot of us got them right. Questions on number 1? All right, let's do this. Okay, this is chapter 6, section 4, the triangle mid-segment theorem, okay? Remember, guys, today, after today's lesson, we are going to do a GimKit as long as GimKit's working. It was down earlier, but I think it's back up. Remember, the winner are the best. All right, mid-segment definition, a segment that connects the midpoints of 2 sides of the triangle, and every triangle has 3 of them, and it forms the mid-segment triangle. Mid-segment triangle. And that's just that little red triangle that you guys see in the middle. Okay? M, N, P. Triangle M, N, P is our mid-segment triangle. Who can tell me, why is a mid-segment different than a median?
Because it's not on the line, it's inside the triangle.
Okay. Where does a median go? A median starts at the middle of a side. That's where these are starting. But where does a median go?
On the inside of the triangle.
But it connects to what point?
opposite side.
That's our mid-segment. This is our mid-segment, right? I'm talking about a median. Where does a median go?
In between, in the middle.
If we're starting from M and we want to find the median, one of the medians of this triangle, where would we connect M to?
P.
That's a mid-segment. That's what we're learning right now. Median was something from lesson 6.3. What's a median, guys? A median goes from here to C, okay? I heard someone say C. Thank you, Juliana, okay? A median goes across to the opposite vertex. See how a mid-segment is different? It goes from one midpoint to another midpoint, okay? It goes to both midpoints. Mid-segments are different than medians. We need to know that, okay? All right. Next slide, the mid-segment theorem. So the segment connecting the midpoints of two sides of a triangle is parallel to the third side and is half as long as that side. So DE as a line segment is a mid-segment of ABC, and it is parallel to AC, and then DE equals 1/2 AC.
Mr. Yurko,
Yeah,
can you go back to the last slide, please? I missed the last one.
sure. I'll go back after this one, okay? Or actually, I'll go back at the end, Kale, okay?
All right.
Just remind me. Okay. So let's say we're not done with this slide. Let's add a midpoint between A and C, and let's call it F. Okay? Let's call that F. And let's say it's the midpoint. So it divides this into two equal parts. So guys, DF. What line segment or which side is DF going to be parallel to?
FE.
FE. So FE is this one. Parallel. Remember, parallel would be going in the same direction. What do you think, Noah? BC, very good. How'd you get that? Uh-huh. Very good. So Noah just noticed that these two are going in the same direction, okay? The other way you can think about it, okay, so where F is the mid-segment of AC, right? D is the midpoint of AB. So what's the last side that we didn't use? It's just BC. It's going to be that third side, the side that we're not using for the mid-segment, okay? Where did my pen go? Okay, so for FE, E is the midpoint of BC, F is the midpoint of AC. Which side didn't we use? AB, okay? So this side must be parallel to this side. So not only is the mid-segment 1/2 of that other side, but it's also parallel to that other side. So what we would say is EF is parallel to AB, and it's also 1/2. So DF was 1/2 of BC, And then we also know that EF is 1/2 of AB. This is just a theorem, okay? It's called the Mid-Segment Theorem, but it includes two properties. The fact that those line segments are parallel, and also that they're 1/2 the other side's length. Guys, all we've got are some examples, and then we're done, okay? So our example 1, triangles are used for strength in roof trusses. In the diagram, UV and W or VW are mid-segments of SRT. Find UV and RS. All right, so SRT is our triangle. I'm going to go ahead and outline it with a highlighter. So SRT is the triangle that we're looking at. And it tells us that UV and VW are mid-segments, okay? That means that U is the midpoint of SR. V is the midpoint of ST. And W is the midpoint of RT. So midpoint, midpoint, and midpoint. So on SR, SU is going to be the same length as UR. SV is going to be the same length as VT. And RW is going to be the same length as WT. The reason we knew that, guys, is because if it's the mid-segment, it's connected by all of the midpoints. So we know that U, V, and W had to be midpoints. Okay? What it wants us to find out is UV and RS. UV and RS. Okay, and the only actual lengths that were given are RT, which is 90, and VW, which is 57, okay? Now, remember our mid-segments, so from V to W, it told us that's the mid-segment. So this has to be 1/2 of the side that's parallel. Which side of the triangle is parallel to VW? So VW is this mid-segment right here, okay? From here to here. It's going to be parallel to one of the sides of the triangle, SRT. Which side of that triangle SRT is going to be parallel to VW? Very good, UR, right? But the whole side, Teresa, is going to be SR, okay? Because remember, our triangle is SRT. Okay, so SR. So when those two are parallel, okay, the relationship is that SR is twice the size of VW, or VW is 1/2 the size of SR. They're just double or 1/2 of each other. So VW is 1/2 times SR, and SR is going to be 2 times VW. Now we're given VW. VW is 57, okay? So all we do is we plug in 2. We plug in the 57. 2 times 57 is 114. Okay. It also wants us to find what RS is. RS is this bottom, or I'm sorry, RS is, we just found RS, sorry. UV. UV. In order to find UV, okay, that's this mid-segment right here, okay? Whenever we're looking for mid-segments, which side is parallel to UV? Which side of the triangle is parallel to UV? Noah? But the whole side. RT, very good. So RT is the side that's parallel. So let's put two parallel lines there. Okay. Now UW is the mid-segment. Okay, so it's going to be 1/2 whatever RT is. So UV equals 1/2 whatever RT is. And we know RT. RT is what? 90. So we're just going to put UV equals 1/2 times 90, which is 45. So guys, when we're doing these mid-segment problems, you always got to look for, okay, which side of the triangle is parallel to that mid-segment. And then those have a relationship. Okay, this is our mid-segment. Which side is parallel? Okay, then they have the 1/2 and 2 times relationship. Your side is always going to be double because remember, your mid-segment triangle is the smaller one. It's the mini triangle inside. All right, guys, let's see if you've been paying attention. What is the last mid-segment in SRT? It's not RV. That's a median, actually, because it goes from a midpoint to a vertex. S what? ST, nope. It's not drawn here. Remember, mid-segments are from midpoint to midpoint. What's the two midpoints that have not been connected?
UW.
Very good, UW, okay? This is our last mid-segment. Do you guys see how we have a triangle now when we connect all of our mid-segments? That's smaller than the original triangle. All of those lengths are going to be 1/2 whatever the lengths were for SRT. So UV is 1/2 of RT. UW is 1/2 of ST. And VW is 1/2 of SR. Okay, we're going to do another example. Example 2. So we're given R, S, and T are the midpoints of the sides A, B, and C. Complete the table. Well, first, let's fill in some stuff. What's CR going to be equal to? You right?
Yeah, I choked on my spit.
AR, very good. What about AS?
BS.
Yep, BS. What about TB? CT. Why are those equal? Because they're midpoints. Okay? Midpoint, midpoint, midpoint. Because it said that they're well, it told us that they're midpoints. But we now know that RS is now the mid-segment, RT is now a mid-segment, and TS is now a mid-segment. Okay? So AB equals 12, BC equals 14, and AC equals 18. ST, that's this line segment right here. ST. What is ST? Well, in order to figure out ST, we need to find which side of the triangle is parallel to ST. Which side of our exterior triangle is parallel to ST? What'd you say? AC, very good. Excellent. So whatever AC is, if we divide it by 2, that's going to be the length of ST. So AC was 18. We divide that by 2, we get 9. RT. Well, RT is this one. Which side of the triangle is parallel to RT? Go ahead, Noah. What's that? AB, very good. So whatever AB is, RT is just going to be half of that. AB is 12, so RT should be 6. RS. What side of the triangle is parallel to RS?
CB.
CB. So CB is going to be 1/2. RS is going to be 1/2 whatever CB was. So what's RS? 7. Okay, so if BC is 15, BC is 15, what mid-segment does that tell us information about? If BC is 15, we're looking at the second one, okay? I want to use this information, BC being 15, to help me figure out one of the mid-segments. If BC is 15, which mid-segment do we have information on now? RS, very good, because they're parallel, okay? It always gives you information about the mid-segment that's parallel. So RS is going to be 1/2 of 15, or just 7.5. Or 15 over 2, okay? All the same. AC is 22. If AC is 22, what mid-segment do we know information about now? ST, very good, because they're parallel. What's ST going to be?
7.5.
Nope. AC was 22.
Oh, then 22.
So now ST is going to be? 11. Very good. So the mid-segment's always going to be half whatever your original side was. So now it gives us RT, which is 10. RT. If RT is 10, what side of the triangle do we now have information about?
AB.
AB. Okay? So if RT is 10, AB is going to be 20. You see how it changes? When it gives us a mid-segment, Teresa, you have to double it to get the side. Do you see it now?
Yeah.
Okay, so let's try AB. Is AB a side or a mid-segment? A side. So that gives us information about which mid-segment? RT. Very good. So AB relates to RT. So RT is going to be double or half? Half. Very good. So it's going to be 5. Okay? ST is 9. What can we conclude from that?
AC, 18.
Ah, AC. What is AC going to be?
18. 9 over 2.
18.
Oh, because you have to double it.
Mm-hmm. Depends on which way you're going, right? RS. If RS is 7.8, what do we know?
BC is 2 times RS, so 7.8 times 2, which is...
Good. If RS is 7.8, we just multiply that by 2. And 7.8 times 2 is 15.6 for BC. Are we starting to kind of understand it now in terms of mid-segments and their sides? The key here, guys, is just to figure out which side is parallel to the mid-segment, and then those two have a relationship. Okay. Example 3. Use triangle GHJ where A, B, and C are midpoints of the sides GH and BC. What is GH? Say it again. Oh, yeah. So this whole side is 7x minus 1. And then BC is 4x minus 3. Okay? Using those two expressions, what do you think we should write in terms of our equation?
7x minus 1 equals 2, open parentheses, 4x minus 3, close parentheses.
7x minus 1 equals 2 times 4x minus 3. How on earth did you come up with that? Because you're right.
It's parallel, so it's double.
Good. If they're parallel, they have to have a relationship. These two are parallel, right? If they're mid-segments, and it told us that CB was a mid-segment, so then they have to have a relationship of 1/2 or 2 times. And if you multiply CB by 2, you're going to get whatever length GH should be. Okay? All right, so in order to solve this, all you got to do is distribute that 2. We've got 7x minus 1 equals 8x minus 6. What do we do from here?
Add 1.
Subtract 7x, good. And then we're going to eventually add 1. Or no. We'll get, what? -1 equals x minus 6. And then we can add 6 to both sides. And we're going to get 5 equals x. Are we done?
No.
No. What do we have to do?
We have to find GH.
We have to plug it in. To which one?
7x minus 1.
Good. So we're going to write GH equals 7x minus 1. We're going to take this 5, plug it in there. So GH equals 7 times 5 minus 1. So GH equals 35 minus 1. 34. And guys, I didn't put this, but please put this. You should put up top that CB, or 2 times CB equals GH. Just so you know where that equation came from. 2 times your mid-segment will give you the length of the opposite side, or the side that's parallel. So we just took GH, which was 7x minus 1, and we set it equal to 2 times whatever BC was, or CB.
Once you're done with this slide, can you go back to the first one, please?
Yeah, sure. I think KL wanted that one too.